Okay, so welcome everybody. I was going to finish the last part of last week's tutorial. I remember we were doing a walkthrough of one of the functions for milestone 1, specifically the function that let us get the street segments that connected to or impinged on an intersection. And we wrote that function by calling the streets database API, but it wasn't fast enough. If it passed performance, it failed the speed tests. So at the end of the tutorial last week, we talked about how can we make that faster. And we said, well, we could preload some data in load map. And to get access to it from the rest of our program, like when we're called and asked questions about what street segments impinge on a certain intersection, we're going to need a global variable. So global variable that we're using, we called intersection street segments. Global variables should tend to have pretty descriptive names because they're visible to the whole program, so they shouldn't have short names. This one's got a nice long one. So for every intersection, what are the street segments? And we decided that an appropriate fast data structure for that would be a two-dimensional vector. So the first dimension, I'll go back here and actually no, it's coming up in a minute. The first dimension is going to be indexed by the intersection ID, which is just an integer that conveniently starts at 0 and goes to the number of intersections minus 1. So it's a good match to a vector. And then at every one of those intersection IDs or intersection indices, we're going to store another vector. And that vector is going to actually be the street segment IDs that are the answer. Okay, so we're going to load that in our load map function, which can be reasonably slow. We can spend a fair amount of time here because it only happens once at the start of our main program. So our load map has to load in the lower level APIs. So we're going to load streets database bin for the map that we've been told to load so that we can call all those functions we talked about in streets database API. And then we can do anything we want. Okay, so what we want to do is want to load up this global variable so that we can have it be used in our query function later on. Okay, so you probably haven't seen this before, right? Nested vectors. So I've got a vector of vectors. So that's like a 2D array. It's fairly similar. The first dimension is indexed by intersection ID. So there's data for intersection 0, there's data for intersection 1, there's data for the last intersection, size minus 1. And for every one of those entries in this first dimension, I've actually got another vector, okay? And that other vector is just a vector of integers, which are street segment indices. So let's say the first, let's say intersection 0 has 3 street segments that impinge upon it. And let's say they were 311, 321, and I don't know, 299. Then that's what I would store here. 311, 321, and 299. Okay, so I basically got the answer of what street segments connect to intersection 0 right here. Okay, and so on for every single intersection. So intersection 1, the answer is right there. Intersection 2, and so on, all the way up to, in Toronto, it's about 150,000 intersections. So here's what the data would be for the 150,000th intersection. Okay, let me erase that. I was just saying what I said. Okay. So I need to load this up. I want to use it in my query functions. I need to load it up. So I'm going to actually put you in breakout rooms. I think we've got enough time, and have you take maybe just a few minutes, maybe 3 or 4 minutes, and try to code this routine in load map. So you're going to need get num intersections, how many intersections are in the city map, and you're going to need the functions that we talked about last week. So if you don't remember them, grab these tutorial slides so you can look at them. Okay, so let me put you in a bunch of breakout rooms, and we'll come back in a few minutes. And just type this in a text editor, and you can paste it into the chat when we come back. everybody. How many people think you got an answer? If you got an answer, type yes. If you didn't get one, type no. Just get a sense of how many people were able to come up with something. It might not be perfectly correct, might not compile. It's hard to write without a compiler, but how many people got down, yeah, I think this would work. Okay, so I got one no. So yeah, if you couldn't get it, that's fine. Just write in they couldn't get it too. Gives me a sense of how this breakout room went. Okay. So at least a couple of people found they couldn't quite get it. Yeah, without looking back at the notes from last week, you also couldn't probably get it. You need to get the description of the functions that you can call. Okay, so let me show you my solution. Our solution, the teaching team solution. So the first thing that we do is, and there are multiple ways to do this, but here's what our code does, is we basically create the first dimension of the vector. And we can use this resize member function to do that. Okay, so if you go look on c++.com, you're going to find that for vector, there are all sorts of member functions. One of them is resize. So you're not going to remember all the member functions. You go there all the time and look, hey, what are my options? This resize member function is convenient. What it does is it says, take this vector, intersection street segments, and make this many entries in it. So it says, I want its size to be a number of intersections. And now my first dimension of the vector has been created. Okay, so there's an entry 0, there's an entry 1, all the way up to, this num intersections minus 1. Okay, they're all, now this is a two-dimensional vector, so what is actually there? Well, right now it's an empty vector. Okay, but all of the entries now exist, and they have an empty vector inside of them. That's convenient because now I can refer to any one of these entries with the square bracket operator. So I'm going to loop through all my intersections. So start at intersection 0, go through all of them. And for every one of those intersections, I'm going to say, well, how many street segments are there impinging on this intersection? Maybe it's 3, maybe it's 4, maybe it's 6. And then I'm going to, for that count, maybe it's 4, I'm going to go through and just like we did last week, I'm going to ask, give me the ID of the street segment for that intersection. Give me the 0th one, give me the first one, give me the second one, give me the third one. And if there were only 4 of them, that's how many times I would go through this loop. Okay, so I'm going to get each one of those street segment IDs that is touching my intersection. Okay, so if that's intersection 0, I'm going through all these street segment IDs, and I'm pushing each of them back, so I'm adding them into a vector. Which vector? The vector for that intersection. So the first time I go through, it'll be intersection 0 that I'm building up the vector that I'm storing for it. Okay, so I'm basically pre-computing the answer for every single intersection, what are the street segments that impinge upon it, and storing that answer in this vector. Okay, so that is referring to a specific vector in my two-dimensional data structure, and I'm putting the street segments for that intersection into it. Make sense? Okay, so it seems like people are with me. This resize is convenient in this case, because if I use pushback instead, it's just a bit more of a pain. It's convenient for me to make the entire first dimension of the vector, and now I can basically just refer to any intersection I want using the square bracket operator. Remember, you can't create entries with the square bracket operator, so if I didn't use this resize, I'm going to have to do some kind of pushback here to create the entry that we're about to work with. And I found it easier to code if I just created all the entries for the first dimension of the vector at once. Okay, so what do we have in our find function now? So our find function now becomes very short. So remember, this is the function we wrote last week, and we said find street segment of intersection for some intersection ID. So we pass in, say, intersection ID 0. We want to get back to street segments that touch it. It's just one line long. So if we passed in street segment or intersection ID 0, we would look up the entry 0 in our two-dimensional vector, and we would just return that. So we return the whole vector that is stored for that intersection ID. And this will work for every intersection ID because we pre-computed the answer for every single intersection ID. So this is as fast as it gets. We do basically a single access into a vector, which is order 1, and we return the data that's there. So it doesn't get any faster than this. If we do that, we pass our speed tests. So we moved complexity from our find function into our load map function, and now our find function is faster and passes the speed tests. You can't make load map infinitely slow, but you can make it pretty slow. It only occurs once. When you run your main program, a load map is only going to occur, when you load a city, and then you're going to do a lot of drawing and interacting with that. So it's okay if load map takes a while. It's like the startup time for the program. So we give you several seconds, and that's enough time that you can do a lot of pre-computation. Let me ask you one question. What is the complexity of this function? So I just put this block of code inside my load map. What's its computational complexity? Any ideas? So if we have, n intersections in a city, yeah, it's basically order n. So it's dominated by this. We've got a big loop here. It's going to go through n times. And then for each one of those, it actually goes through and asks for every single street segment. That's a small number, like k. K is like 4. So you could say it's order n times k, but k is like the number of street segments that touch an intersection, which is bounded to something like 4 or 6 or 8. So you could also say, well, that's essentially order n, because k is not very big. And that's okay in load map. Load map, because it has several seconds, order n algorithms are all right. If we ever had something that was order n squared, that's not okay. That's going to take minutes to hours, so that's going to be a problem. But order n's okay. Any questions on that? So I was just finishing off the milestone 1 walkthrough. If there are no questions on that, we'll move on to today's topic, which is code style. Okay, so it looks like there are no questions. So let's go on to today's topic. Okay, so why does code style matter? So code, you write it once and it's read many times. Be modified many times by yourself, your teammates. If you're in industry, it's modified often for years, even after you've left the company. So it's important that that code is easy to read and understand. In fact, it's something that we don't teach it as much in school, but you in industry spend more time reading code than writing code, because you figure out, how do I fit into this system? What's the problem? How do I enhance this? So being able to read code is actually a really important skill. Code that is hard to read is bug prone, because it's hard to reason about. You don't really understand what it does. It's difficult to modify because you can't really modify code that you don't understand, and it's hard to reuse. People are going to be scared about reusing that code because they don't really understand it. And it may have all sorts of unknown side effects. So we're going to give you some principles of how to write readable code. And a few of those principles I'm listing here are the key ones. The length of your functions, so try to keep them short. Variables, name them well. And try to have your variables have limited scope, meaning they're not alive for very much of your program, so you don't have to keep as much in your head. Comments should give the big picture. Don't duplicate code, and there are lots of other things you can do to make your code more readable. We'll talk some more about it in lecture, but it's something that you get better and better at with practice, just like you get better at writing clear prose as you write more and more essays and documents. Coding is like that. You start by writing code that may not be the most elegant and easy to read, and you gradually get better at it as you get feedback on it. So the guiding principle is that you're trying to reduce cognitive load. So programming requires understanding a lot of details, and humans can't actually keep that many details in their heads. So there's a famous study by Miller that basically said that humans can keep about 7 things. It varies a little bit across people, but 7 plus or minus 2 items is how many things they can keep in their short-term working memory. And this is actually why phone numbers are 7 digits. So now you have them all on your cell phone, you probably just click on people's names. But before that, it was important to be able to remember them. And people could remember 7-digit phone numbers, but they couldn't remember 9-digit phone numbers very well, or certainly not 10 or 11 digits. So that's why phone numbers are 7 digits, and then you have an area code. But the area codes don't change that often. So we're trying to do the same thing in code. We're trying to minimize how much people have to keep in their head because they can't keep that much. The other thing you want to do is you want to explain why. So if you've written readable code, people can read it, they can understand, okay, the code does this and then it does that, but it still doesn't say why it does that. What were you thinking? Why did you organize it this way? What is your underlying algorithm? You know that when you write the code, but you may not be around for people to ask you, so you got to put those comments in your code. You may even forget yourself. I go back to code that I wrote, months or years ago all the time, and I don't remember. Like, I'm happy for my own comments, right? So, because they tell me what was I thinking, why did I do it this way, and I forgot. Okay, so let's dive into that in a bit more detail. So functions, you want to keep it short, and probably shorter than you think. So if your function is longer than about 10 lines, it smells. So smells means, okay, it works, but I'm a little worried about this. This doesn't seem like the most tasty meal. I don't know if I want to touch that. How do functions get long? Well, sometimes people just write long functions, which is bad because you should follow this rule and try to break it up into multiple sub-functions. A long function, you should be writing it as a shorter function, calling shorter helper functions. Often people do that when they start, but then as they find more cases, more features they need to handle, they'll just keep adding lines. So I'll just add 2 more lines to this function, it'll be fine. As this goes on, eventually the function gets too large. So what you have to do is watch for that and then periodically refactor. Refactor basically just means it's like editing a draft when you're writing an essay. You have a draft, you're going to go in, you're going to rewrite parts of it to make it more clear. So refactoring code's the same thing. It works, but we're just going to restructure it so that we have shorter functions, clearer code. Long functions are hard to read, they're hard to understand, they're hard to maintain. And I'll show you some examples that hopefully convince you of that. Shorter functions force you to name parts of your code. Part of why they're easier to read is that you have, for example, 10 lines of code and it's in a function with a name. The name, if you've chosen it well, should tell you what those 10 lines of code do. And when you're reading other code, you just see calls to that function. It documents your code a lot better. And obviously it organizes and structures your code more too. It's much more likely you can reuse that function if it's short. Okay, variables, you want to use good variable names. So they should describe what's in the variable and what its purpose is. And the reader shouldn't have to go look at the declaration and initialization of the variable to figure out what it's for. You also want to minimize the number of variables that people have to keep in their head, and that's because of that working memory limitation. So you do that by not having that many variables in scope. So let me type this in the chat. Do people remember what in scope means? What do I mean when I say in scope? So you can remember this from 244 or 105. Maybe not. So the in scope basically means like alive. You can access them from this part of the program. So global variables are always in scope. You can access them from anywhere, which means you really want to be careful about having a lot of global variables. You have to have some in this project. Try not to have too many because that increases cognitive load. Give them good names because that helps. I'm going to show you some other techniques in this tutorial about how to minimize how many variables are in scope or alive, which helps you understand your program more easily. Temporary variables are kind of interesting. Having too many temporary variables that just rename other variables can reduce the readability of your code because you're again creating more things for the person to keep track of. Sometimes you call this variable I and sometimes you call it J, but it turns out they both mean the same thing. That's not great. On the other hand, sometimes temporaries can help you name sub-computations, much like a function, if you give them good names, and can help you break up a long sequence of computations and make it easier to understand. So they're a little bit of a judgment call. Okay, and I'm gonna put up this code, and let's see, I'll start a poll. So start looking at this code, and I want you to tell me what you think of its style. Okay, so let's see. See if I can actually relaunch this poll. Yeah, there we go. Okay, so take a few minutes and just look at this code, which is related to one of the milestone 1 functions. So it's kind of actually useful code for you to look at anyway. And tell me what you think in terms of its style. And let's see, Harshit has a question, should you make variable names similar to the type defs? So Harshit, are you asking, like, should the name of the variable be similar to its type? Is that what you're asking? Like, in other words, if for this project, if you have an intersection ID, should you have intersection ID in its name? Yeah, often that's a good approach. So your name may have more than that, but making clear what it is by having a name that's similar to its type, when it's something like an intersection ID that people know what that type means, does make sense. You wouldn't want to, if you have multiple intersections that you're working with, you wouldn't want to call them, you know, intersection ID 1, intersection ID 2, intersection ID 3, if there's more meaning to them than that. But you might call them, you know, inter ID left, inter ID right, that kind of thing. So now it's clear this is an intersection ID, and if there's something else you should know about it, then that's also part of the variable name. So it's actually why often when you create classes, classes and types in C++, you'll start this is a common coding convention, it's one I use. You'll start the name of the type with a cap. So you might say intersection index, so that's the name of the type. And then a lot of the variables might start with like either intersection ID or something. Like you could actually give a variable the same name with a lowercase start. So you don't necessarily want to give it exactly the same name, but that's why types usually start with a capital. So you can tell it's a type, and often people want to name their variables with a very similar name. So if they start with a lowercase, it works. It's legal, it's syntactically legal. Okay, so it looks like everybody's taking a shot at this, so let's share the results. And, okay, so nobody thought this code was perfect. 18% thought it was good, with minor improvements possible. 64% thought it was fair, with significant improvement possible, and 18% thought it was poor. So yeah, this is pretty aligned with what I would say, and I think what the TAs will say. I'd probably rate this code as fair, but both, you know, good and poor are not unreasonable. Right? There's some judgment call about what this is. So type in the chat if you have any thoughts of why. Okay, so nobody thought it was perfect. So what could be improved? Okay, so comments, yeah. So there are no comments. So that's not great. Should be comments. Anything else that they should improve? Yeah, so some of the names are maybe not the best. Lat long 1, lat long 2. That could be more descriptive. Kind of tells you what kind of variable it is, but not much of what it's used for. Yeah, no vertical spacing. So this is all one big block of code with they've indented, which is good. Not indenting is terrible. It's like writing an essay with no punctuation and no capitals. Enrage your CI or TA, so always indent. But they haven't used any vertical spacing. They've run all the lines together, and you can make things more clear with vertical spacing. So those are all good points. In terms of comments, the most important comment would be a function comment here, because I don't want to read this whole function. If I'm somebody working in your code base, if I see somebody calling this, I want to know what does it do just by reading the comment. So I want a comment right here above the function. Maybe I need comments within it too, but I really want to see that one. Tell me what this thing does. Tell me if there are any assumptions or anything I need to know about the algorithm. Tell me that at the top. Okay, so it's exactly what Emily said. No spaces between the lines. That was the first thing that that I flagged as well. So they basically help break your code. Vertical whitespace breaks your code into essentially paragraphs. It serves the same purpose as a paragraph in an essay. You can see related code. So let's say we do that. So we put in these vertical spaces. It is a bit easier to read. Okay, we can see that, well, these two things kind of go together. This if statement is a block. These two lines go together, and so on. So it does make it easier. Next thing to notice is I said it's good to minimize the scope, basically where your variables are alive. And this function is using kind of an older style of programming convention. Some people do this because early versions of C, you had to declare all your variables at the top of a function, all your local variables. Some older programming languages, same thing. Recent versions of C and all versions of C++, you don't have to do that. You can declare variables basically wherever you want. So better practice is don't declare them at the top of your function, declare them right before you need them. Okay, so if we look at some of these variables, you declare length here, and we don't use it until way down here. And we set it equal to 0, but by the time we get down here, we may not remember that it was set equal to 0. Now, it doesn't turn out to matter in this case, but we've kind of separated the initialization from the use, which isn't a great practice. It's a source of bugs sometimes, so people don't remember what was initialized to. And all this code might have changed length, so I have to kind of keep in my mind what is length. If you look at these ones, there are these distance variables, dist first, dist last, and so on. And they aren't used until way down here. Okay, so those variables are declared way at the top, and then they're not used until we get to the else statement. So again, why did I have to even think about them then if I wasn't going to go read the else statement? So we can change that. We just don't declare them at the top of the function. We declare them right before we use them. So here's the change, right? So I was declaring all these variables up there, and now I just declare things like length right here. I'm going to declare those other distance variables in the else, and my cognitive load is reduced. Let me get rid of this poll. And the variable names, this is another thing that was flagged. So the question from Berthola, if we declare a variable inside the if, is the scope only inside the if? Yes. So the rule basically is the variable scope ends when you leave that block of code. So block of code basically means like brackets. Okay? So I declare int1, int2 here, they will cease to exist at that bracket. Okay? I declare length here, it comes into being there, it will cease to exist at this bracket. If I declare these dist functions here, they will come into being when I hit that, and they will cease to exist, well, not at the return, they will cease to exist at that bracket. Does that make sense? So it's actually a generalization of the rule for functions, because this local variable in my function will cease to exist when I hit the bracket ending the function. So basically that rule isn't just for functions. It works for all, blocks of code, and a block of code is basically whatever's between the brackets. Okay, so it's also flagged by Persona of the variable names they're not that descriptive. Okay, so inter1 and inter2, at least it says they're intersections, so that's good. It doesn't say they're IDs, so maybe I should have also had like the word ID in there. I've lost some information. I used to know that which one was the from intersection and which one was the to. So basically we've got a street segment, and we've got the from intersection, and we've got the to intersection. Let's see. Yeah, so I've lost a bit of information with this variable naming. And the same thing with lat long 1 and lat long 2. I don't know which one is the from and to. Maybe that doesn't matter in this function, but if it mattered, then this isn't the best naming. This name in particular is bad. Okay, so it's just ID. It's a specific kind of ID. This is a street segment ID. Okay, so this ID is referring to the street segment. I'm going to have a lot of IDs floating around, intersections, street segments, etc. So this isn't a great name. Okay. The other thing to notice here is I have a lot of temporary variables. So I have this intersection 1, intersection 2, this lat long 1, lat long 2, this length that don't live for very long. So length, I declare it here and then I immediately return it. That's the only purpose of it. Inter 1 and inter 2, I just grab from my street segment info the from and to. So they're not doing a whole lot of work for me. So you just ask, are those temporary variables making things easier to read or harder to read? Okay, so let's make some changes. So let's try to improve our variable naming and let's try to avoid some of these temporaries that seem like they might not be needed. Okay, so that ID was probably the worst variable name. So we're renaming that to be street seg ID. This name's not great either. Info, that's not a very descriptive name. So let's change that to seg info, right? Or I could call it SS info for street seg info. But this gives me a hint now of what everything is. I got a street seg ID and I've got a segment info. So that's a bit better. I can also eliminate some temporaries. So here I've got this temporary, these two intersections, and this is, pretty short. Let's just try getting rid of these temporaries, which are just used to send information into this function call, get intersection position. If we eliminate them, what's the code look like? Well, it's shorter. I actually got rid of 2 lines of code, and to me, this code does not look overly complicated. So get the intersection position of the from intersection that's on our segment info. Okay, so we got our segment info, we got a from, we got a to, and yeah, it's seg info. So our variables are better, and I think this is easier to read. Any thoughts? You can type it in if you think that's easier to read, but I think it is. Don't like these variables too much. Lat long 1, lat long 2. If I call them, I'd rather call them positions. So that's kind of a personal style thing, but pause to me is a little more meaningful. And I'm going to put in the from and to, so I remember which one is which. That might be important to me. Turns out in this routine that actually knowing which one's the from and to down in this else statement can actually be useful. So these are going to be better names. And here's another temporary. So I set length equal to just this function, find distance between 2 points, and then I immediately return it. So I probably don't really need this temporary. It's not really helping me with readability. Let's try eliminating it. Now I return find distance between 2 points. My code is shorter, and it doesn't look too complicated on one line for me to read it. So I think eliminating some of these temporaries has actually improved readability. Code's shorter, easier to understand. Okay, so what do you, I would argue that this code is now significantly easier to read. Hopefully you agree. So we could keep doing this. So we've eliminated a bunch of temporaries, but these are still temporaries. This pause from and pause to are just used to pass information in there. So we can say, okay, let's get rid of those temporaries too. Let's see what that looks like. Okay. So if I did that, I wind up with just one line in my if statement. And it looks like this. Get intersection position of seginfo.from. Get intersection position of the to intersection. Pass those 2 locations in space into this function that finds the distance between 2 locations on the planet. So what do you think? Is this good or bad? So that's option 1. Eliminate those extra temporaries. This is option 2. Keep those temporaries. So just type in the chat. What do you like better? With temporaries or without temporaries? So that's with temporaries. And that's without temporaries. Okay, so I see 2 withs, 1 without, 2 without. So yeah, there's no perfect answer to this. This is one where one of the TAs and I, had opposite opinions about this. But I personally like the with better. I find if you eliminate too many temporaries, you start doing too much on one line, this can start getting hard to read. So someone now has to kind of parse, okay, wait a second, I got this function call and this function call and then this function call. Whereas I find the temporary variables with good names help you see kind of show your work. You're seeing how am I building up the answer. So I find this one easier to read, although this one's not terrible. So sometimes temporaries improve readability, they kind of add information, they show your partial work. The other thing they do, and this is why another reason I do prefer this one, is when you're using a debugger, you can single step over code. So you can say execute just the next line of code, and you can examine the variables. Now execute one more line of code, and so on. So with this code, I can actually be in the debugger, and I can basically look at, I can say execute one line of code, and I'll now go to here, and I can look at pause from. And then I can say, okay, step one more line of code, and I can look at pause two. And then I can say one more line of code, and I can look at what this function returns. So I can watch these temporary variables in the debugger. And I find that helpful. In this code, it's more difficult. If you tell the debugger to just step over this whole line of code, a whole bunch of stuff happens. So you probably have to tell it, okay, I'm going to go inside those functions and watch them more carefully. So it's doable. You can still watch what's happening, but it's a little more tricky if you have a lot of things happening on one line. So the debugger's it's a little more difficult to observe the state in the debugger because you don't have these convenient temporary variables showing you your steps, and you can watch them in the debugger. Okay, so this was before, and this is the version where we kept some temporaries because that was my preferred version. I like eliminating most of the temporaries. I want to give better names. I want to push the scope of the variables as small as I can, but I don't like to get too much work on one line, so I like to keep these two temporaries. And this code is significantly easier to read. It's actually shorter, but it does the same thing. It's vertically spaced, better names, easier to understand. Okay, so that was all about code structure. And you can see even in that little routine, you can do a lot by just thinking carefully about your code structure. Comments. So you should have comments. Most people don't comment enough. You should be describing the overall structure of your program and data structures. So give the big picture. Describe why design choices were made. So why are you using this kind of data structure? Describe the goal of some code. And if there's a complicated algorithm or some tricky code, then explain that, or there's a special case you don't handle. But before you do that, try to make the code clearer. If you have to write a big comment just because you wrote code that's confusing, think about, does the code have to be confusing? If there's a tricky algorithm that you need because that's the only way to make it fast, then fine. Keep it and write the comment. But if it's complex for no good reason, then rewrite the code. Don't leave commented out code in your project. So Git has all your code history. So if you had an old version of this function and now you have a new version, just delete the old version. Nobody wants to look at it. It just pollutes your code base. And don't translate code to English. So, if you have a for loop, for int inter id, equals 0, ... and you say this is a for loop of intersections, that's pretty obvious, okay? So you don't need to write that. If you wrote above it, loop through all intersections and compute this and store it, okay, that's a higher level comment that's explaining, what this whole loop is doing. That's more useful. But just saying this is a for loop over intersections, I could already tell that. So that comment's not very helpful. Okay, don't have duplicated code. So if you have duplicated code, it can probably be extracted into a function. So this is a sign you don't have enough small functions. And it was likely copy and pasted. So copy and pasted means there's some code that basically does what I want. I just have to change some of the variable names. So I'll just copy it and paste it here. That's a common source of bugs because people forget to change some of the variable names, and it makes your code longer and therefore harder to modify and harder to understand. So here's some code that actually is also relevant to milestone 1 for a particular function. You don't need to worry about exactly what this is doing, but basically we're going through all of the street segments. There's a big for loop, and for every street segment we are basically getting the from intersection. Okay, so for a street segment, SSID, it's got a from intersection and it's got a to intersection. And we're basically, if we read the comment, it says we're taking, let's see, I gotta read this carefully again. Okay, so basically we're looking at this from intersection, and we're saying if this particular street segment that we're looking at, SSID, is not a duplicate for the list of street segments that we have that connect to this from intersection, then we want to put it in our vector, okay? The vector that we were talking about earlier, intersection street segments, so that stores what are all the street segments at every intersection. So we're basically saying for the from intersection, add this street segment ID if it's not already there, in the vector that we have for this from. And then down here, if you read through this, it looks basically the same. It's doing the same thing for 2. Okay, so what do you think of this code? Do you like it? Do you not like it? Seems easy? Seems hard? So just type in the chat. Like it? Don't like it? What would you change? And just from a readability point of view, we're not talking about functionality. Just like what, don't worry about exactly what it does. Just is there anything you would do to make this easier to read? Anything in it that bothers you? Okay, so Harshit says he likes it. Anything here that, there is something we could do to make this more clear. Okay, so at least one thing. What do you think? Can you give another 20 seconds or 10 seconds to just type it in? It's the last chance if you got an idea. You can be bold and type it in. Type def instead of auto. The auto doesn't bother me actually, because the auto is just get street segment info. It wouldn't be bad to put the variable type here, but the auto to me is okay here too. It's the street segment info. Probably this is not a great name. So SS is pretty short. So I would agree with you there that I would probably call that something like SS info. So that's not a great name. Maybe set a variable for intersection street segments SS from. Maybe could do that. Yeah, it has quite long and it appeared a few times. So I think Lindy's comment is kind of the key one to me on this one. I've got some repeated code. This function is longer than it needs to be. It's kind of a pain to read. It's kind of detailed. So we've got almost identical duplicate code. And anytime you see code, even just a few lines that look duplicated, you should think, why is that duplicated? Why don't I have a function that does that? This code and this code look almost the same. Is there any difference between what they're doing? This one's doing it for the from intersection. This one's doing it for the to intersection. Even the comments say that. The comments look the same, except one says it's doing, it's adding something to this vector for the from intersection. The other one says it's adding something to this vector for the to intersection. So it's repeated code. Should be a function. You probably missed this. In fact, I even missed it in the first tutorial. This is from. That's been changed to, and there's one more in here. To, and actually there's one more from. So we got from. We got to, and what's that? That's a from. That probably should have been changed to a to. So we have a cut and paste error. Somebody's gone, okay, yeah, I did it for the from intersection, let's just copy it for the to intersection, but they forgot to change one of the variable names. Really common variable, really common bug, hard to see, right? Like you look at this code and it's difficult, you go, yeah, it looks the same, but you forgot to change this one variable. Difficult for someone to notice that. Andrew noticed it actually in the first time I did this tutorial, I missed it too, so it's not easy to see. Okay, so bad. We should extract this into a function. So if we extract it into a function, we give it a name, and let's call it insert unique, because that's what we were doing here. We said put it in the vector if it's not already there. So we'll give it a name, call it insert unique, and now we call that function for the from intersection, we call it for the to intersection, and in both cases we pass in, what is the street segment we're talking about. And if it's not duplicated, if it's not already there, we're going to stick it in the vector. This is a lot easier to read. It's a lot easier to read because it's shorter. We've also given a name to what we're doing. So that name already tells the reader, what am I trying to do? And often that's all they need. You're not even going to go look at this function. You're like, yeah, that's fine. Okay, it's going to insert it if it's not already there. Got enough information. Keep reading down, down below. So you've reduced their cognitive load. So much better. What do you think about these comments? So we got 2 comments here. Okay, make sure the ID is not a duplicate for the SS from intersection ID. Make sure the ID is not a duplicate for the SS2 intersection ID. Do you like these comments? Think we should delete them? Could we improve them? Yeah, so Priscilla's saying they could be combined to one comment, and that's a good insight. These again they're almost like the duplicated code before. Like we basically put the same comment in, but just we changed the variable name. But it's kind of obvious that this one is one variable and that one's a different variable. That's probably not the most important thing to comment. This comment also could get out of date. If anybody ever changes this variable name, this comment will now probably be wrong. So not the best. So they're a bit wordy, a bit repetitive. We can rewrite it, and we can use our vertical space trick to basically say, okay, well, these are basically can be grouped together, and let's group them together with the comment too. So this whole block of code just adds the street segment if it's not a duplicate, and we do it for the from, and we do it for the to. Shorter with grouped related code, easier for a person to kind of read with low cognitive load. Okay. All right, so that's it for code style in this tutorial. We'll talk about it in lecture as well, so you get some more rules there and examples. Good code style reduces your cognitive load, so it makes it easier to understand. You don't have to keep as much in your head, and it explains the why. Someone who's good at reading code can read the code and figure out what it does, but they can't figure out why you did it this way. Maybe you didn't think of something, or maybe you had a really good reason to do it this way. Some aspects of good style: short functions. This is one that people will violate a lot. Try not to violate it. Use descriptive variable names. Limit the variable scope. So minimize globals, and within a function, declare variables, when you need them, rather than all at the top of the function. Your comments, the valuable comments, are the big picture comments. How does this all fit together? Why am I doing this? What's the overall goal? And don't have duplicate code, which having short functions will help you with that a lot. Okay, so there's lots of discussion on how to write readable code. As I said, it's really important because of the fact that code is read much more than it's written. And there's some online resources. So Google has a good style guide for C++. Let me just click on that. It's very detailed, so it's going to have more information here than you care about. It's going to be talking about parts of the language that you probably aren't using, so that doesn't matter. So I wouldn't read it in great detail, but if you're curious, you can skim it, and the high-level ideas they have are certainly good. And if you want to read lots of details about do's and don'ts in C++, you can go as far as you want. But we're not looking for extremely detailed coding rules, which sometimes get also a bit controversial. What we're looking for is essentially things that everybody agrees on. What I talked about with meaningful variable names, short functions, etc. Every coding style guideline agrees that those are all good things. Okay, and that is all I have for today. I'll stay on the line in case you have any questions. And have a good week.